So what is this multi-threading and how to write the programs for the threads, for creating the threads and all we try to learn in this session, right? So without your knowledge, whenever you're working with Java programming language by default multi-threaded. That means what? Whatever the programs up to now we have written, whatever the programs we have executed, each and every Java program is by default a thread based, right? So every Java program runs as a thread only, right? So apart from this, the by default thread which is created by the Java to execute your programs, so as a programmer we can also create our own threads. As a programmer we can also create our own threads, right? So before creating our own threads and writing the codes to create our own threads and running our own threads, right? So what actually this multi-threading, right? So I can say like this multi-threading is one of the feature of Java which is given by this programming language inbuiltly. So Java supports this multi-threading inbuiltly. Before Java programming language, this concept is not supported by any other programming languages, right? So it is very much similar to the multitasking, absolutely, right? So Java supports it inbuiltly. That is the one of the feature. Multi-threading is one of the feature of Java. It is supports inbuiltly, right? So executing multiple parts of a program concurrently is called as what? Multi-threading, right? So executing multiple parts of a program concurrently is called as a multi-threading, and each individual part is called as a thread, right? So up to now you will be writing multiple parts of a program, and executing multiple parts of a program concurrently is called as what? Multi-threading, and each part is called as what? A thread, and each part will have its own path of execution. Each part will be executing in its own memory location, right? So this is what here we are going to learn here. So up to now whatever the programs we have written, they are executed as a single unit. Like if your program is having multiple different parts, each part of your program is executed as a single unit. No, now I am going to execute the different parts of my program, right, differently, concurrently, and each part of the program is said as what? A thread, and each part will have its own path of execution, right? So as a user of the modern operating systems and all, it is not a new concept to you, all right? So these modern operating systems, whatever we are using, all these modern operating systems achieves the same concept in a different way, right? So in simply I can say multitasking, right? So multitasking, there are two different types of multitasking coming to Java. We can say one is process based multitasking, right? So one is process based multitasking, and the second is called as thread based multitasking. There are two different ways coming to Java. Actually we call as multitasking, and this multitasking is two different types, right? The first one is called as process based multitasking, and the second one is thread based multitasking. So these two we can evaluate. So these two things generally you can see here. So what is multitasking here? Right? So this multitasking, as we defined, it is two different ways we can achieve this, right? So process based multitasking is as whatever you are going to do at operating system level. So in the process based multitasking, a process is treated as a basic execution unit. Right, and which is achieved at operating system level. That means, so in simple, right? So here Now here I am taking a class, I'm typing the programs, I'm using some software to talk to you, I'm typing the program, at the same time I'm drawing something, right? At the same time, lots of things I'm doing. Now in the general also we'll be doing all these things, right? So whenever you listen a class, you can download a file over a network from the internet, and you can listen the music, you can watch a movie, and you can text your program, and you can compile, and you can execute multiple tasks are performed at the same time. That is called as what? Multitasking. And it is of two types here. One is process based multitasking, and the other one is what? Thread based multitasking, right? So just here, this is what some document here. So multi-threading is a specialized form of what? Multitasking, right? So multitasking is because it is supported by all modern operating systems. However, there are two distinct types of multitaskings: process-based multitasking and thread-based multitasking. So it is important to understand the difference between these two, right? So it is a most familiar form for you, right? Because it is achieved at operating system level. So a process, in essence, a program that is under execution. So a process, operating system level, a program which is under execution is called as a what? A process, right? So a process-based multitasking, in a process-based multitasking, is the feature that allows a computer to run two or more programs concurrently. A computer to run two or more programs concurrently, right? And process-based multitasking enables you to run a Java compiler. This is the example you have, right? So here in the process-based multitasking, what is the smallest dispatchable unit here? A program is the smallest unit. A program is a smallest unit. So this is achieved at operating system level. Alright. So it is not different whatever we are going to do here. Right. A thread-based multitasking environment. A thread is the smallest unit of a dispatchable code. This means a single program can perform two or more tasks. A single program can perform two or more tasks, right? So I can say, right, so both are the same things here. So this thread based multitasking, whatever we are talking about, this we achieve at a Java programming level. This we achieve at a Java programming level. Now as a programmer, I am going to execute multiple parts of my program concurrently. I'm going to write a program in which the multiple parts of my program I'm going to execute concurrently, and that is what each part of my program is said as what? A thread. And it is right, so it is almost similar to whatever the operating systems, these modern days operating systems are performing for you, executing multiple programs, right? So the differences here, if you observe the differences here, so this process based multitasking, we can say it as what? It is heavyweight. Why it is heavyweight? Why what is the reason of it is calling it as heavyweight? Right, this is heavyweight, and the thread based multitasking is what? A lightweight. So I can say thread is a lightweight process, and which is executed under a program. So what is the meaning of heavyweight and lightweight here, right? So in general, if you discuss here, right, and the other one is what? Lightweight. So what does it mean here? Now how these how these programs are executing at a time? Is it really possible to execute multiple programs at a time? Right? So generally operating systems uses some kind of algorithms to do this. Right? You might have heard about some kind of algorithms like time slicing algorithms, round robin algorithms, priority algorithms. Operating systems uses different algorithms, right? Time slicing is the one, and priority algorithms are one, and round robin algorithms are one. Like these different algorithms are used by different environments, yeah, and they use, right? Let's suppose multiple programs are executing under one environment. Let's suppose multiple programs are executing are there. So is really multiple programs are going to run at a time? Right? So here generally when multiple programs are running at a time, one program is given a chance to run, right? Let's suppose that is time slicing or something. If you take the time slicing kind of algorithm here, right? So this is a huge RAM memory. Let's suppose assume that all applications which has to be executed should be loaded into the RAM, and it is a huge RAM memory here, and this RAM memory will be divided and can be given to what each process can occupy this RAM memory and all. So like this, so every process will be loaded into the RAM memory and they can share this RAM memory and all for execution, and each process will be executing in its own memory space. Each program, I can say, will be executed in its own memory space. So let's suppose if you take the example like let's suppose if the time is given for this process, right, actual time which takes to complete this process is, let's suppose, 10 minutes, and the time which takes for this process to complete is, let's suppose, 5 minutes, and the process to complete this, let's suppose, it takes again 20 minutes. Let us assume this. So all these are going to be executed concurrently or simultaneously here. If it is single processor, it is at a time it can execute only one process. It cannot execute multiple processes at a time. Then how it is happening here? So what happens if it is single processor? What happens if it is single processor and uniprocessor kind of thing? What happens? The first program which comes in should complete, then only the other program will be given chance. Then it should complete, then only the other program will be given chance, like this. Then only it is possible, right? So unnecessarily the other programs should wait for the first program to complete, like this. So such kind of operating systems are older generation operating systems. They used to do. They are what? Uniprocess. Is it really is going to execute multiple processes, multiple programs here, multiple applications here in this, right? So generally, as I told you, there are some algorithms are used for this. So let's suppose take the example of time slicing. There will be a scheduler, right? In the operating system level, there will be a scheduler. Let's suppose it is scheduled 1 minute time for this process to execute. Then it has scheduled 2 minutes time for this process to execute, right? Then it has scheduled, let's suppose, 3 minutes times for this example only I'm giving here. It depends on the operating system and environment which you use. It may be priority algorithms. Generally, priority algorithms are used. This is time slicing I'm using, right? So here, let's suppose the whole process to complete it takes 10 minutes, and the scheduler has allocated 1 minute time for this. And whole process to complete this one is 5 minutes. The scheduler is allocated 2 minutes for this. Then here 20 minutes, and the whole process and the scheduler is allocated 3 minutes for this. So what is the meaning of this? How they are going to execute, right? So let's suppose this first process is started executing, and after 1 minute the scheduler will remove this process from this. After 1 minute the scheduler will remove this process out of this memory, and it gives the other process for time for execution, or it may give the same process for execution, right? So after 1 minute what it is going to do here? After 1 minute it is going to switch. Generally we call this as what? Context switching. Context switching means what? So all these threads, all these processes shares the same context area, and in the context area only one process can execute, global, right? Once the process comes out from that context, then it will be given, other program can be given a chance to what? Load into that context and execute it. Are you following me what I'm trying to execute? Let's suppose there is a one global area where at a time only one process can be executed. So this process is loaded into this global area context, and it is started executing. After 1 minute what your scheduler is going to do? It is going to, let us assume it is remove this process from this, and it has placed this process inside it. After 2 minutes it is removed this process, and it has kept again the process which is removed from this memory, it has kept it inside it. Then so what is the thing, what is the meaning of this, right? So the process which takes 10 minutes to execute, so the scheduler has given opportunity to execute it, and after 1 minute it is removed from this. Again when it is loaded back, to this process, where it should start execution? Again from the first. Right? So that means my question here is, In this 10 minutes, it has to execute 1 to 1000 instructions. In these 5 minutes, let's suppose it has to execute 1 to 500 execution. It has overall statements to be executed are 1000. Here you have, let's suppose, 20,000 statements to be executed in overall statements to be executed here. Now actual time takes for this to complete these 1000 statements is 10 minutes. And it is started executing. It is started executing and it is kept into what? This context. Right? It is started executing. After 1 minute, it will be removed. Assume that it is removed. And the other process is kept inside. Right? For execution. And after 2 minutes, it is removed. So in this 1 minute, whatever the first time it has given, in this 1 minute, it has executed 100 statements. It has executed how many? 100 statements out of 1000. Now when again it is given the chance to execute, so where it starts here, where it should start here, where it left the control, right? So that is what happens here. Sometimes when you work with this Windows kind of operating systems, when you are doing multiple things here, if one program is going to hang, your machine is going to hang. So then generally what you do here, you open the task manager and you will remove the process which is hanged, and the remaining process still continues. Yes or no? This problem you might face, right? So let's suppose you are running multiple programs at the same time. If one program is hanged, all remaining programs also will not work for you. So what you do, you open the task manager and you kill that process which is causing the problem for you, and then the remaining programs works in the same way, right? So actually I can say at a time, if you are using a single CPU, at a time only one process can execute. But as a human being, we cannot catch up the speed. It's microseconds, each process will be given as time. So we cannot catch up the speed, so that we always feel like I can say all things are happening at the same time, right? So this is called as what? Context switching. Here we call as context switching. What is the meaning of context switching? Switching one process, switching in between the processes. So when one process switches out from the context, and when the other process is loads, and when again the option is given for the process which is come out from this context, and as you are saying here, it should start executing from what? 101 statement, because it left the control at 100 and it start executing from 101 statement, right? So generally this is where the machines uses PC registers and all, and whatever the processed information is there for 100 statements, it should load all this data again into the memory, and again it should use the data. So that is where the registers and all these things comes into picture, right? So this is what we have here. So this is, if you see this task, loading, removing the process from the memory, as well as assume that I am explaining only two things here, so everything will be same. You cannot guarantee which process comes in, which process goes out, right? Just I am taking two things. You cannot say anything. It is completely operating system implementation dependent, right? Right. So you have that. So assume this. It is huge. It is huge here. So giving an option for one process, again removing it, again loading it along with its data, previous processing information and all. It is huge. So it is heavy. That is the reason why these are called as heavyweight. Right? So this is a reason why they are called as what? Heavyweight. Right? I think there is a spelling mistake. Right? Now if you see the same concept, if you apply the same concept to threads here, then why they are lightweight here? Right? Because a thread will occupy the memory which is allocated for what? A program. Because part of a program is said as what? A thread. Part of a program is said as what? Thread. Here also we will have a context switching in between the threads. So if you are using a single CPU, only one thread can be executed and all. But whatever the memory allocated for a program, a thread shares, all the threads of that program will share what? All the threads will share the same memory. Everything is same. The context switching between the threads and all. So each individual part here, each unique part here within a program, we call it as what? A thread here now. And that is the reason why they are lightweight. That is the reason why what? They are lightweight processes. The concept is same here. One is achieved at operating system level and the other one is achieved at Java programming level. They are similar. There are two different forms of what? Multitasking. There are two different forms of multitasking. One is achieved at operating system level and one is achieved at Java programming level. Now coming to multi-threading, we as a programmer, we give a very little guarantee here, because now your first thing is this thread multi-threading is depends on what? Process based. What is the meaning of this? All Java programs will be executing under what? A virtual machine. First operating system should allocate the time for virtual machine, then inside this your program should be allocated as some time. So very less we can guarantee, somehow we can force these behaviors and all, right? So this is what we are going to do here. So what are we going to develop here? So we are going to develop a program and the multiple parts of that program are going to be executed concurrently. Up to now whatever the programs we have executed, they are all what? Simultaneous. And by default is a very important statement to be noted. By default, Java is thread based. By default, if you write your own threads, if you don't write your own threads, if you write a thread, if you create a thread, or if you don't create a thread, by default Java programs are what? Thread based. So what does it mean and all we try to understand here. Let me write one program here. I am not going to write one program. So let us try to take the example. Already I told you one concept while discussing exceptions. I told you this concept again we see in multi-threadings, right? So let us take the same example here. No. Yeah, this one. It's fine now. Right? It is again same example I am taking. I think you remember this program. Right? Nothing is there. A simple program where I have a main method, main start, and through this main method I'm trying to call a method of the same class. Right? Method 1 I'm trying to call here. Nothing is there inside this main start, main end, and it goes, the control moves here, and again you have a start and end, and here I am trying to call the same method of the same program here, one more method of the same program, and it is calling this method, and you can see here. This is what the same program which we have seen in the what exception handling. What is the relation here between the exception handling and this? Just we'll try to understand here. Just I would like to run this program here. Java C, what is that? Exception demo.java. It's fine compiled, and exception demo.class. See there, as expected, yes, because there is an exception which I did not handle, and always you will see what if the exception is not handled. Always you will see a stack trace. So you got a stack trace here. Now if you clearly read this, so every method is started but no method is end. No method is completed its execution because of there is a exception is raised, and if you clearly observe, read this, that the type of the exception, message, and this is stack. And but here there is one important statement to write. What is this? Exception in thread main. What is the meaning of this? Exception in thread main. What does it mean here? Right? So by default every Java program will execute under a thread. If you by default, that means when a program starts executing, there is one thread will be created for you. There is one thread will be created for you. That thread is called as what? Main thread. The thread is what? Main thread. That is output. I think you can read it, right? Exception in thread main. What does it mean here? So there is one thread is created by your runtime, and this thread is always a main thread. It is called as what? A main thread. which is always created by the runtime. So every Java program will be executed as a thread only. It is a thread based approach only. But this thread I have not created. This is by default created by your runtime. And what actually the meaning of this stack here, right? So this thread has its own way of executing this program. That means this main thread always starts its execution by searching what? A method called as what? A main method. It always starts its execution by searching a method called as a main method. Right? So that means now this is called as stack. Already we have discussed Java methods are what? Stack based. Now main thread starts searches for a method, and that is main method, and if it is finds, then it loads that method into the memory. Right? So execution starts from main method. So this is how the stack will be constructed now. This is how the stack will be constructed. This is what here? This is a method. Now from the main method, what I'm trying to do here? From the main method, I'm trying to call a method called as, what method I'm trying to call here? Method 1. This is how the stack grows. And this stack is for which thread? This stack is for a main thread. Now on top of this, you will see a method called as method 1. And on top of this, you will see a method called as method 2. Like this your stack grows. That means, so by default one thread will be created, and this thread will have it is, I am not putting them, it is by default. There is a methods are stack based approach, right? So this is not created by me. So you can see this stack here. This is how the stack is grows. The same thing here you can see here. Main thread, and its stack is like this. First main method in this stack, then method 1 in the stack, and method 2 in the stack. See this. The stack starts from this, executes from main method. So what is this here? So there is by default one thread is created. Its name is main thread, and its first method in it is what? Main method. It searches for a main method. If it is not found, your program will not be executed. Main thread will not start executing here. So let's suppose if I comment this, actually it is 1.7. It gives you a different message here, right? It is saying what? Main method not found. Main method not found to execute it. It is searching for a main method, and if it is not found, it is not executing. Right? So actually, if it is 1.6 kind of software, then you can see some other different message there, so that it is clear to understand. Invalid flag. Why invalid flag? It is there, right? Hyphen source. Java C hyphen source space 1.6 space the class name. It's fine. It is compiled. Why first time it was not compiled? C is missing. Right, let me run this program. No, it is, I cannot use source here now. No source you can use here. No, you cannot use source here. Generally what it is saying here, it's always a program when it starts searching. This method which is created searches for a main method. If it is found, then the stack will be grown. From the main method, it is, I'm calling method 1. So on top of main, method 1. So it starts executed, and in the middle it is found a method 1. It goes here. This will be placed on top of main, and in the middle it has found this one, it will be placed on top of what? Method 1, like this. The stack grows like this. And in the same way stack will be unwinds. This is how the stack grows, and this is how the stack is going to be come down, unwinds. Because I did not handle the exception, this is not handled here. In this area not handled, in this area not handled. There is a reason why your runtime is showing you. But in this thread, whatever the thread you are trying to execute, in this thread there is a problem. And that problem is here, not handled, here, not handled, not handled. So this thread is terminated abnormally. This thread is terminated but abnormally. That is the meaning of this error message. I think you can understand this message more clearly, right? Now when I compile this, right? So if I compile and execute it, you see the same message. It's not a new thing I'm explaining here. So to make you understand that Java programs are by default threads. If you create or if you don't create, they are by default threads. Now what my intention here is, right? So what I want to do here, what is my intention here? Now I don't want to execute my program. This is a single thread and this is a single thread. What is the meaning of single thread? So there is a problem. What is the meaning of single thread? So method 1 should wait until method 2 to complete. Main to wait until method 1 to complete, and main should complete. Then only your program is completed. So this is single thread. So method 1 should wait until method 2 to complete. If it is completed, then only method 1 can start. Then method 1 should wait, main should wait until method 1 to complete. Then only main start. So this is single thread, and in all my methods, all my parts of my program are executing in the same thread. Now what I want to do here, what is my intention here? I don't want to execute my program like this. I don't want to execute my program like this. I want my methods, each part means what? Each method, I can say, right? Each method of my program I want to execute what? Individually. So I want to execute method 1 separately, just for, right? I want to execute method 1 separately. So executing this method 1 separately we call as what? A thread. So I need to have some memory location, right? So what is the meaning of this? If I want to execute my method 1 separately, not on top of what? Main. No. I don't want to execute on top of main. If it is case, if you want to execute your method 2 also separately, you can. So executing these blocks of your program separately is called as what? A thread. So separating these pieces, separating these actual parts of your program is called as what? One thread. Method 1, if you want to execute this method 1 separately, it is one thread. If you want to execute method 2 separately, it is one thread. Right? So like this I want to do. This is what I want to do. So that what happens here? So these parts of your program, will be executed concurrently. So the code inside the method 1 will be executed. At the same time, the code inside the method 2 will be executed. At the same time, if you have method 2, the code inside the method 2 also will be executed. So there is no dependency here. Previously there is a dependency. What is the dependency here? Method 1 is dependent on method 2, main is dependent on what? Method 1. If anything goes wrong in the middle, main is also not executed. See that? What happened here? Because the previous methods are not completed successfully, main is also not completed. Because the method 2 is not completed successfully, method 1 is not completed. I want to execute these parts separately, independent of each one. That means what? If there any problem occurs in method 2, main should not, there is no effect on the main. So main should continue its execution. If there is something goes wrong with method 1, still main will execute. There is no problem with what? Main. If main has a problem, no problem. Your other part of your program can execute without depending on this. So that is what we are going to do here. That is what a thread is, right? So each part, each executable part of your program, each separate part of your program, whatever you are executing as a separate part is called as what? One thread. And there is by default one thread will be created. That is always what? Main thread. Okay, are you following me? So this is what I am going to do here. So instead of executing all program as a one thread, I am going to split my program into different pieces, and each piece I am going to execute as a what? Separate unit. So that what I'm going to do here, I'm going to create my own thread. What does it mean here? I'm going to create my own thread. Creating my own thread means what? Creating a own thread means what? Right? So creating my own thread means what? Allocating some separate memory. Right? So that is whatever the memory which is allocated. So I'm going to allocate my own separate process. I'm going to create my own separate process, and into this process I'm going to load the code which I want to execute. From the actual process, whatever the process is there, from that I am taking some part of program out and I'm allocating some separate process for this, and I want to execute this as what? Separately. Getting me? So this is what I am going to do here. That is the meaning of what? A thread. Right? So there is a meaning of a thread here. Right? So here, inbuilt support you have for multi-threading. So a multi-thread program contains 2 or more parts. Multi-threaded program contains 2 or more parts that can run concurrently, and each part of the program is called as a thread. So by default there is one thread is created for us that we call as main thread, and I am going to separate and every part of your program will be executed under main thread only. Every piece of your program will be executed under main thread only. Yes, as a programmer you have provided a facility that you can separate these pieces from the main thread. That means what? Separating a piece from the main thread. Separating a part from the main thread is called as what? You can create your own thread here. Right? You can create your own thread, nothing but you can create your own process, and whatever the code you want to execute, you can execute it under that process. That is what multi-threading is. Do you understand what I am going to do here? It's very simple to write the program. This concept is a bit difficult to understand, but the program is very simple to write. Are you following me? Yes, everybody. So if you don't write your own threads, what happens here? What is the meaning here? If you don't write your own threads, that means what? Every piece, every part of your program will be executed under the same thread. Single thread. If you don't write your own user-defined threads, yes, still the Java program is thread-based. That means every method, every part of your program will be executed under a single thread, that is main thread. And whatever the programs up to now I have executed till this date, all are thread based only. But this thread I have not created, that is default thread created by the Java runtime virtual machine. Java virtual machine is created it, and every method of your program is executed under the same thread. Now what I want to do here, I want to create my own thread. I want to create my own thread, and in that I want to execute some part of my own thread. That means what I'm going to do here, right? So this is what here, a big picture, a simple diagram I'm going to draw here. So what I'm going to do here. So by default one thread will be created. What is it? By default one thread will be created. This thread we call as a simple diagram I'm drawing here so that you can understand. Main. And it will always, definitely it will have its own stack. Definitely it will have its own stack. So your program execution always starts with what? Main thread. Always your program execution, the first thread which starts executing your program is main thread only. Right? Main method is different, main thread is different. Main is a method which goes under main thread, which executes under main thread. It is a method which executes under main thread. You will understand what does it mean. Let me write 1 or 2 programs. Then what I'm going to do here, actually what I'm going to do, if you don't create your own user defined threads, every thread, every part of your program will be executed on the same stack here. Every method will be placed on the same stack, and every thread, every part of your program will be executed on the same stack. Now that I don't want to do here. I want to do different. I want to create my own threads here, and I want to execute them separately. That is what I want to do. Right? So that means what here? What I'm trying to do here? I want to create my own thread. And very interestingly, this thread also we create from what? The main thread only. From the main thread, I am going to create my own thread. From the main thread only we are going to create it, because this is the starting point. So what is the meaning of creating your own thread? I want to execute some part of the program separately. That is what here. I want to execute some other part of the program separately. That means, but now for this, in this thread, what I want to execute here, in this thread, this is a one more thread I am creating. Assume this. So I am creating my own. So what is this here? This is a user defined thread. I want to execute my own method inside this thread. Let's suppose I want to execute my method, which is there, method 1 inside this. This is what I want to do. So this is my own thread, user defined. Let's suppose I'm calling it as a what? Thread 0. So what does it mean here now? What is the meaning of this program now here? What is the meaning of this diagram here? So by default there is a thread created for you. This is called as main thread, and it will always start executing a main method. Always it starts a main method. Now if you don't create your own user defined thread, the method one should be executed under what? Main. No, I don't want to execute method 1 on top of what? Main. I want to execute it separately. I want to execute this as separate from main. So what I need to do here, I need to create what? A thread. And creating a thread means what? Allocating some separate memory, right? And where I can run my program, where I can run my method. Getting me? So what happens here? Method 1 will execute and main will execute concurrently. There is no relation between now these two. It will execute in its own memory location which is allocated for it, and it will execute in its own memory location which is allocated for it. So two different parts of your program can execute concurrently. That is what I am going to do here. So if there are 100 statements to be executed inside this, you cannot guarantee how many statements from this will be executed, how many statements from this will be executed. Both will be executing concurrently. That is what? Thread. That is what I am going to do here. Right? So each thread will have its own path of execution, and that is not that only one method will be there. The main method can have its own other methods in its stack, right? So don't assume that only one method here. The main method can have other methods in its stack. Absolutely fine. Method 2 can come here, or it can have its own stack. Absolutely, it's fine. The stack may grow like this. But some part of my program I want to execute separately. Some piece of my program I want to execute what? Separately. So this is what I am going to do here. Did you understand what I am trying to do here? So what advantages I will have doing such kind of programming? That is first thing need to be understand. Right. So what advantages we have here then? Right. So whenever you do such kind of things, so first thing is utilizing the memories efficiently, your memory. Let's suppose if it is uniprocess, all memory will be occupied by the same memory. Let's suppose your RAM, some kind of memory have RAM and all. So it is let's suppose 512 MB. In this 512 MB, at a time only one process can execute, and actually that process takes 10 MB only. What about the remaining memory? It is simply wasted. Getting me what I'm trying to say here? If your RAM is having some memory, and in this memory, if this memory can be utilized by only one, and it is not complete again, only 10 MB is required for one process to utilize it. RAM memory is required. Then what about the rest of the memory? So completely making use of what? CPU resources. making use of CPU resources efficiently, we go for this mechanism. As well as it reduces what? Time also very, you can utilize the CPU memory as well as what? Time of the CPU, because multiple threads multiple processes can run what? Concurrently, right? So this is what we are going to do here. So how can we write such kind of programming? We try to understand here. As a programmer, we are not going to do much task here, very simple task. Okay, shall we write the program then? So are you clear what I'm going to do here? What is the meaning of multi-threading? So that it is meaning to write it, right? Again, nothing different here. Again, simple object orientation inside this. If you want to do multi-threading in Java, again simple object orientation inside this. It's not a complex task to do. So creating a user-defined thread. So what I'm going to do here, so apart from the by default thread which is created by the virtual machine, I'm going to create my own thread. And what is the purpose of creating own thread? So you want to execute some piece of code separately. That is the meaning. Creating your own thread means what? Creating your own thread means what? You want to execute some piece of code separately from what? The main thread. Otherwise, no need. Every code, every part of your program will be executed under the same thread, that is main thread, right? So there are two tasks, I can say. I can divide this entire program creation into two different things here. One is, in Java, creating a thread means what? What is the meaning of creating a thread is a simple thing here. Creating a thread means there is a by default class is given for us, a predefined class is given for us, and this class is from lang package itself. And creating an object for this class is nothing but creating a thread. And this class is what? Java.lang.thread class. This is the meaning of this. Instantiating, not creating the class actually, instantiating a java.lang.thread class. It is a predefined class. This is the meaning of creating a thread object. It is a object. Right? Simple, right? So creating an object for a class called a class, and that class is called as thread class, java.lang.thread. So nothing is there. Thread t is equal to something. You need to see the constructor which is there inside this class, and you need to use that constructor to create the object. Very simple. Student s is equal to new student, account a is equal to new account. This something is equal to new this. In the same way, thread some t is equal to new thread. You need to find out the constructor whether it is there or not. If that constructor is there, we always create the objects by using the constructors of that class. The second thing is thread of execution. What does it mean? I will tell later. Thread of what? Execution. Thread of execution means what? Thread of execution is the most important thing. Thread of execution means what? So creating a simple object for that class is not sufficient, right? So you should allocate some separate memory. The memory should be allocated for the part of the program which you want to execute separately, and that is called as what? The memory should be allocated for the part of the program which should be executed separately, and that is called as thread of execution. Is the most important thing out of these two. Okay. Two things. What are the two things here? First thing is, as a programmer, first of all you need to decide. As a programmer, first of all you need to decide which piece of your program you want to execute separately. Yes or no? First of all you need to decide which piece of code in your program you want to execute separately. Then afterwards, there should be some memory allocated to load that piece into the memory and execute that piece of code separately. That is what thread of execution. Right? Thread of execution means what? The piece of code which you want to execute separately from the main thread, it should be loaded into the separate memory and it should execute in its own memory. That is what you have here, right? So this is a is only multi-threading, but creating a multi-user defined thread. What is the meaning of creating a user defined thread? As a programmer, I am going to create my own thread. Creating my own thread means what? Part of a program I'm going to execute separately from what? Main thread. So that is what I'm going to do. So remember, these are the only two things I'm going to do. Very simple. How many threads or how many predefined threads you can create? All threads will be creating by using the same mechanism. Instantiating a thread class and thread of execution. Thread of execution means the part which you want to execute separately from the main thread, load them into separate memory and execute it, right? So for this, now I'm going to write a program, very simple program, but try to understand this. I will explain the program later, why this program is behaving like this, right? So again, we take the help of API so that you can clearly understand what I'm going to explain here. Very simple, very simple. But so here, this is the API which I'm trying to open. And what is that class? Lang. Again, class from this thread. This is the one I'm talking about, right? Same thing. Public class thread extends object. What is a thread here? A thread is a thread of execution in a program. Right? A thread is a thread of execution in a program, and the virtual machine allows an application to have multiple threads of execution running concurrently. Right? So that is what? Thread means what? A part of a program, and virtual machine allows you to execute multiple parts of a program concurrently. And you should identify what parts of your program you want to execute concurrently, and then you can execute them concurrently from what? Main thread. What is the thread class here? It is a predefined class. It is a predefined class given by the Java people. I have not created it, right? That is a problem if you miss the classes in between, right? Now let us try to understand this here. Public class, I'm creating my own class. So the first thing is, can I create a child class for this class? Is it possible for me to create a child class for this class? Absolutely it is possible. Why? Because it is not a final class. If a class is not final class, we can absolutely always create a child class for it. We can absolutely create a child class for it, right? Now I'm doing the same thing here. My thread extends thread. THREAD. Very simple program here. So thread is a predefined class and it is from lang package. No need to import anything. Because it is from lang package. Lang package class are set as what? By default. Fine. This is what we have here. Nothing I'm doing here. Now first thing is, whatever the code you want to execute as a separate piece. But there is a point to be remembered here. Always that code should be kept inside one method. And that method is called as, always the method's signature looks like this: public void run. What is the method here? Whatever the piece of code you want to execute separately, that piece you should always keep inside what? A method called as run method. A normal method, instance method only. What is this? Instance method. Yes. Now I'm going to write some simple for loop for this. Int I is equals to 0, I less than or equals to 100, and I plus plus. right? A simple. So what is this? Remember this point, the first point I said, right? The piece of code which you want to execute separate as a separate unit, always that code should be kept under run method. Now from this run method, if you want to call main method, if you want to call method 2, method 1, method 2, all these things, whatever you want to call separately, you can call all them from this piece that we see, right? Just I'm keeping up. No, you cannot change it. The method name always should be run. It should be always run. The piece of code which you want to execute separately, it should be always run only. Definitely it is not possible to change it, and the syntax also should be same. Run with the return type void, no arguments. Right? So I would like to print the I value. Yes. You will understand why I have written this. Don't worry. I did not complete it, right? Once I complete my explanation, then you ask your questions. Absolutely, I'm free to explain. Right? Same thing here. Control O, Z here. C. Nothing I'm doing here. 2 for loops. Nothing special about this program. Very, very ordinary program I'm writing. Inside this, let me, instead of I value, I would like to write run method. And I would like to write a what? Main method. Simple. So that we first program will keep simple. So here, this is my program done. Writing my program is done. What I said here, as I told you, right? One thing I completed. What is it? The piece of code which you want to execute separately, always that piece should be inside run method only. There is the first rule, fixed rule. You cannot modify it. And the signature of this rule, signature of this method is like this always. Now I have separated my piece which I want to execute separately. That is done. Right? Now how to call this run method? How can I call this run method now? How can I call this run method? Yes, very simple. Create the object for class which is where run method is exist. My thread empty is equals to what? New my thread. Right? And empty dot what? Run. Simple. I am not discussing any new concept. Whatever I discussed up to now, I discussed it. Now I said like this. Now let's see here. Whatever the 2 points I said previously. What are the 2 points I said? Instantiate. The first thing is separate the piece which you want to execute as a separate piece of code. Which the piece of code which you want to execute separately, separate it. So I'm saying that separate piece always we write inside what? Run method. I did it. Right? Yes or no? Execute, separate the piece of code each whatever you want to execute separately, and always that piece should be there inside what? Run method. I did it. The second point, if you see this, what I said here, instantiate the class means what? Create an object for a class called as what? Thread class. Did I do this? Did I do this? Absolutely I did it. I did it. What does it mean? It is a child class for what? Thread class. That means what? The child class object also becomes what? Thread child class object also becomes what? Super class. Super class. It can call everything from what? It's super class. Right? Yes or no? The object of this class becomes what? Thread object only I can say. I can say what? This object I can refer with thread also. Subclass object can also be referred by what? Super class. Yes. Yes, absolutely. All methods of thread class you can call from my thread. So this is the object I have created, and this is a thread object only. Why? Because my class is a subclass for thread class, and absolutely I have created object for thread class only. Indirectly, I am calling this method. So that's it. Do I completed my two things here? So I'm saying instantiate the object for thread class. Directly I'm not instantiating it, but indirectly I'm creating object for this class. And I said what thread of execution means? Separate the piece of code which you want to execute separately. That means what? What is the diagram I'm expecting here? Diagrammatically, if I represent it, what I'm expecting here is always there is one thread will be created. That is what? A main thread. Yes, this is the first one. And it will have its own stack here. And what is the stack you have for this? And always into the stack the method goes here is what? Main. That is what we discussed. And whatever I want to execute separately, yes. I don't want to execute that method on top of what? Main. So I want to create my own thread here. I want to create my own thread here. Right? And I want to execute what? I want to execute this run method separately. This is what I want to do. So I want to execute some part of my program separately, and that piece I have written, and I want to execute inside this. That is what my program execution is now. That is what my program execution. This is what actually I want to do, right? Did you understand this diagram? What is this? I want to create my own thread. Main thread is already there. Main thread is already there, and I want to create my own thread. And into this I want to execute it. Main thread starts. Main method will be executed in separate memory area, and run method will be executed under some other separate memory area. This is what I want to do. So that means what here? So what happens? Main method's 100 statements are there inside this for loop in the main method. I want to execute these 100 statements separately, and I want to execute these 100 statements separately of run method. Yes, that is what I want to do. That is my intention. Are you following me? So these 100 statements I want to execute separately, and these 100 statements I want to execute separately. Yes or no? That is what I am going to do. So that now let us run my program here. What is my program name? Let me compile this. Java C my thread.java. It's saying illegal start because of these operators should not be separated. Always I will do a mistake in this operator. This is a single operator, we should not separate them. It's a compilation problem. So this is where the important observation. Oh, where you find it is executed the statements. But observe these statements. Now what happened in my program? Run method, and it is started. Run method is started and it is completed its execution. 100 statements, then main started, main is completed. Let's see. Let me run one more time. This observation is very important for my next explanation. What happened again is the same story. What is happening here? Are they really executing concurrently? Are they really executing concurrently? Yes. Run is started, run is end, main is started, main is end. Are they really executing concurrently here? How many times I run? The same thing. So what is happening here? What is happening here? I am saying concurrently. Concurrently means what? You cannot guarantee which should execute how many statements, what. But it is always giving the same. Simultaneously, it is also not simultaneous. Okay, fine. It is not, I can say, right? But the problem here is, right? So let us do one thing then, right? What I'm doing here inside this is, I'm going to write some thing here. What I'm doing here? Something. What happens here? I 0, 0 by 0, exception is thrown, right? Okay. Just I'm throwing the exception. Now let's see, let's observe this, what it is going to do. So there is an exception in run method, but nothing, no problem in main method, right? Let's see what happens here then. Oh, very bad. What is happening here? Is it created a thread for you? No, it is not created a thread for you. Main method. See the stack of this main method. See the stack of this main method. The first method inside this stack is main, and on top of main run is running. On top of main run is running. That means what? What happened here inside this? It is not executing like this. Instead, it is executing like this. Right? Instead, my program is executing like this. That is the reason why run is always completing first, then main is completing. That is the reason why when there is exception in run, main is also not executing. This is the stack how it is created for me now. Are you following me what I am trying to explain? Just I am showing the outputs. According to the outputs only I am writing here. I am not explaining any new things. My expectation was this one. My expectation was this one. I wanted to do this one, but it is not actually executing. Your program is not actually executing like this. Your program is still executing like this only. So what does it mean here? What is happening here? See this. So main thread object is created, and after the object is created, immediately I am calling what? Run method. First what is happened? Main thread is creating. Main thread is created, and into the stack main method is entered, right? Then what is my program is doing? Run method is entered into the same stack, and there is a problem in run method which is not handled. There is exception in run method which is not handled. So it coming to this, and it is searching here in the main method. Still it is not handled. The main method is also not executed. See the output. Seeing what? Saying the same thing. Both methods are there on the same stack of the same thread. Yes? Did you understand what I am saying here? Yes or no? Everybody says the same. So actually what happened here? No thread is created. No thread is created. Every part of the program is executing on a single thread again. In this example, whatever the example I have written, in this example, these two pieces, the main as well the run, both are executing under the same thread. They are not executing separately. Both are executing under the same thread. And what is that thread? And always the by default thread. So, right? So then what I said here, I did the both here. As I told you, like create an object for thread, I did it, and execute create a separate piece, the piece which you want to execute separately, write this piece inside run method, I did it. Then what happened here then, right? So that is where the important part. So both things I have did here, but this object, whatever the object I have created, the object which acts like a normal object, normal Java object, which acts like a normal Java object. So this memory is not allocated. This memory is not allocated here. We want to allocate this memory, and after this allocation, so if you want to create this process thread here, and after creating this thread, you want to load this run method into this memory. So you should not call the method directly on this object. So if you want to create your user defined thread, so always very important point, every area, right? So thread of execution, what is the meaning of thread of execution? Should not call the run method. A thread becomes a thread object becomes a thread of execution, right? What does it mean? A thread object becomes a thread of execution by calling a method called as what? Start method. Always a thread object becomes a thread of execution by calling a start method. What is the start method? What is the importance of the start method? We try to understand. Just observe the program now. I am now confident that it will not execute like this. It will not execute like this, and it will be executing like this. Let's see. Okay, following me. Now let's see. So let me recompile my program and let me execute my program. Is it the same thing happened, guys? Oh, interesting. Now see this. Exception is there in my code. Exception is there in my code. Still the main block is executed. Main block is how the main block is executed for you. And see exception in where? Thread 0, not in main. And see the stack. Only one method. Right? I'm going to remove the exception. I'm going to remove the exception so that you will understand this. Previously main method is not executed, but very fine. Main method is completed its execution, right? It's a CLS, right? I'm habituated to work with Ubuntu and I'm always using my thread. Very nice. Run is completed. Scroll through. What happened? Can you see this? Very interesting output. Can you observe this output? Did you see any difference here? Main, 3 statements. Then run. Main, run. You cannot guarantee this output, guys, again. This will not give the same output always. And the one key point I would like to say by seeing this output, yep. Why it is jumbled? Why it is jumbled? Because of the same story. Right? Because they are not executing like this. Both have their separate memory allocated and both are executing separately. And you cannot guarantee how many statements will be executed of each thread. You cannot guarantee how many statements will be executed. Absolutely cannot guarantee it. Right? Let's see. Let us run. And a very interesting point here to be observed, noted here. Did you see this statement? Which method is completed last? There are 2 methods and 2 methods are executing separately. Which method is completed last? Run, right? Never say the answer like when the main method completes, the program is completed. No. Can you see? Main method is completed. Its execution 100 statements. Main method is completed its execution 100 statements. It is completed somewhere in the middle. Where is main completed? Here. But still program is under execution. Main method is completed but the still program is under execution. That means what? Main method is not completing a main method is not a program completed. Then what is the meaning of program completed? Right? The meaning of program is completed is when all the threads which are created, this thread is created from where? This thread is created from main thread only. See where I have created this thread. I have created this thread inside a main thread. What is the meaning of main thread? In the main method only. So all user defined threads will be created from the main thread only. When all its child threads will be created, all user defined threads killed, then the main thread will be killed. When the main thread killed, then the program is stops. Program is said as what? Completed. Not main method. Main method's completion is not program is completed. Main method is completed, but still your program is under execution. Why your program is under execution? Because your main thread is not stopped yet. When it stops, when all its child threads completes it, all the other threads, user defined threads completes, then the main thread stops. Then the program said as what? Completed. That is the meaning of this output. Don't say, never say the answers main thread is completed, program is completed. Let me run one more time to see this. Is I am going to get the same output here. Run is completed, but I don't think the same output we got here. Is it the same output? Absurdly wrong output. Previously main has executed 3 statements, then run is given a chance, but here different. Did you see the difference here? Is it same output I got? No, it is a different output, because you cannot guarantee. There is what here. You cannot guarantee how much time will be given for each and every thread. Now run is last, but main is here. You can see this is somewhere. Now if you keep on running some time, you can see main is last. Absolutely see the main is last. But one thing is guaranteed here. Very important thing to be noted. One thing is guaranteed in each and every output. What is that guarantee I have here? One thing is guaranteed in each and every output. What is that? Every started thread, if there are no exceptions, every started thread will be completing its execution in the same order. That means, see here, it is executed 0th statement. It is then other thread is started executing in the middle. Then where it is stopped its execution, again it is started executing from the first statement. Then it has executed second statement. Again when main started, it is started from third. Again when main started, it is started from fourth. Again fifth here, 6, 7 here, 8, 9 here, 10, 11, like this it is executing. Every started thread will run to completion in the same way, in the same order. So that is the meaning of a thread. Thread is nothing but what? In simple, I can give a definition. A single, right? What is the meaning of thread here? A single sequential flow of execution. Sequential flow of execution within a program. A single sequential flow of execution within a program, we can say as what? A thread. Right? So main is started in the same order it is completing. Though it is in between, some other thread is coming, but how it is started, how many statements is executed, whenever it starts again, it will be executing in the same order, because it is left the control at 84th statement, it is started again from 85th statement. And you cannot guarantee how much time, how many statements. See here, I'm executing. Each time you are seeing a different output. Definitely cannot guarantee it. And if I cannot guarantee the output in my machine itself, in the same machine, definitely you cannot guarantee the output in other machines. Something you can guarantee, what is that? Every started thread will come to an end if the exception is not there, if something not occurs in the middle. It's fine. Did you understand here what is happening here? So a thread object here, right? The important point in this program to be noted is only two simple things we do always is what? Instantiating a thread here, instantiating a thread, but it will act like a simple Java object. It becomes a thread of execution, right? So when a Java object, when a thread object becomes a thread of execution, when you call a start method on the thread object. If you don't call a start method on the thread object, it will not become a thread of execution. That means that separate memory will not be allocated. And it internally calling the run method. It internally calls its a run method. Okay? Do you understand here? We want to see the output, right? So we will see this exception demo then. R. Okay, I'm going to copy these statements. I don't want to complicate this program. Copy it, the same thing. I'm copying where? Inside this run. I'm copying inside this run. What I'm doing here? This is what? Run start. Double quotation. And run end. Okay. Simple. Again the same thing I'm going to do here. Okay, let me remove this for loop. I will keep that later. I will write that later. Same program. But instead of directly calling a run method, what I'm trying to do here, see here, I'm trying to call run method directly. I'm trying to call run method directly. I'm explaining this program to see just the stack. Observe the stack, what it is created, what is creating here. Very simple program, I think, right? Just for seeing the stack. Only all methods are what? Each method is started, but no end for each method. And the stack is like this, right? Can you see this? No end for main because there is a error in the stack. Anywhere error in the stack, it will not start. Now instead of this run, if I use start, what happens here? Let's see. Is it going to give me the same? Very interesting, right? What happened? Exception is there in my program or not? I did not modify my code. Just I am calling the method in a different way. See? Main is started, main is completed. Run is started. Exception in only run. Why? And exception in what here? Exception in what here? Not main, right? Exception in thread 0. Can you see this? Yes? Or do you understand what is happening here? Let me put exception inside this main also. After starting this thread, I would like to put 2 exceptions are there. See? Exception in thread main and exception in thread 0. But it is printing the output like this. Start messages are coming in between. If I run one more time, same output. If I remove the start messages, you can see. No end you can see here. Is it only one exception? There are actually still the same. See, but clearly it is not displaying you there. But something you can still you can print it very clearly, but by doing something here. So that is what here. The printing is not clear, absolutely. But there are 2 threads and each thread has exception. There are 2 threads, each thread has exceptions. Exception in thread main, exception in thread 0. And if there is no exception in thread main, what is happening here? If there is no exception in thread main, what is happening? Main thread is completing. Main thread is executing successfully, but the other thread is not completed because it has a exception. See here, if you want me to keep that same for loop, int I is equals to 0, I less than 100, right? Just I would like to write a for loop here. Just copy the statement and print it again. Exception is there, so it is there, but main is processing. Where is the exception? In 0, thread 0, right? So main is not right? Nothing happened to the main thread. It is executed separately. So that is what we have here. Simple. So create an object for thread class. First thing is separate this part of code which you want to execute separately, right? And create the object for thread class and call it. Very simple. I don't think it is difficult to understand this program. fine, right? Simple class I have created, Java class, instance method, run method, and I have created object for thread, and I'm calling start method. If you call the start method, then only it happens. Instead of if we call run method here, if we call run method, what happens? Because exception is inside this and it is not handled, main method is also not executes. There's the difference. No run method, right? Because no main method also, because all methods are there in the same stack. So that is how we create the threads, right? So I would like to stop this